Good day, class. Our topic of discussion today in physics is the principle of conservation of linear momentum. This principle states that when two bodies collide, the total momentum before collision is equal to the total momentum after collision, provided no external force acts on the colliding bodies. The diagram below that depicts we have two bodies of mass m1 moving with an initial velocity of u1 and body m2 moving with an initial velocity of u2 before collision, and we have that same body after collision moving with two separate velocities. The first one moving with a velocity of v1 and the second body moving with a velocity of v2. Please take note, class. The two bodies are moving in the same direction after collision. U1 and U2 pointing eastward, V1 and V2 pointing also in the east direction. Now recall that momentum is equal to the product of the mass of a body and its velocity. So from there, the momentum before collision will be equal to m1 u1 plus m2 u2. We are going to sum the momentum because m1 is the mass of the first body, u1 is the initial velocity of the first body, plus m2 the mass of the second body, u2 the initial velocity of the second body. While the momentum after collision will be equal to m1 v1 plus m2 v2, v1 and v2 being the velocities of the two bodies after collision. From the principle says momentum before collision must be equal to momentum after collision. So we have m1 u1 plus m2 u2 equals m1 v1 plus m2 v2. Now class, if the two bodies coalesce after collision, meaning they join together after collision, then we have that equation to become m1 u1 plus m2 u2 equals m1 plus m2 multiplied by v, where that v is what we call the common velocity. Class, we shall use these formulas to solve questions in the next class. Thank you. All right, we have the first example. A body of mass 6 kg moving with a velocity of 10 meters per second collides with another body of mass 4 kg moving in the opposite direction with a velocity of 2 meters per second. Calculate the common velocity in the direction of the body's 6 kg mass after collision. Class, before we solve any physics question, we must read and understand what the question is all about. So it's always advisable to read the question the second time and take note of all the parameters that we are going to use to solve the question. If you look at the question critically, we see that we have two bodies, one of 6 kg and one of 4 kg. That 4 kg is moving in opposite direction to the 6 kg, and that must show in our solution. Now, if you look at the diagram that we have down here, we have the 6 kg pointing eastward. We now have the 4 kg pointing westward, which implies it is in opposite direction to the 6 kg. All these are very important. Anything given in the question must be reflected in the diagram. We can draw diagram just to aid the solution. Take note of that, please. So from here, before collision, we have 6 kg moving in the east direction with a velocity of 10 meters per second. We have the 4 kg moving in the west direction with a velocity of 2 meters per second. Then after collision, we have the two bodies moving in the east direction, because Gordon says we must find the common velocity in the direction of the 6 kg mass, and that 6 kg is moving in the east direction. That is why we have the diagram and the arrows pointing like that. Now our M1 equals 6 kg, our U1 equals 10 kg, our M2 equals 4 kg, our U2 equals 2 meters per second. Then our V, which is the final velocity, is the unknown. Now the formula to use is M1 U1 plus M2 U2 equals M1 plus M2 bracket V. From there, we input the given parameter. M1 is 6, U1 is 10. Now, because the body is moving in opposite direction, second body is moving in opposite direction with the first body, that will affect the sign. You are saying the positive sign will change to negative sign. If the body was moving in the same direction as the first one, it means the sign will remain positive. Please, class, take note of this step. Whenever they are moving in opposite direction, it will affect the sign. So from there, we have 4 bracket 2 equals 6 plus 4 times V, which is the final velocity. So 6 times 10 will give us 60, minus 4 times 2 is 8, equals 6 plus 4 is 10, then 10 times V is 10V. 60 minus 8 will give us 52, equals 10V. Make V the solve formula. We have 52 divided by 10. Then we punch our calculator, we have our V to be equals to 5.2 meters per second. Therefore, V is 5.2 meters per second in the direction of the 6 kg mass. Thank you.